Hello, scientists. We are coming to the end of our unit on physical science, and it's getting close to the time where we're going to take our assessment. But before we do, I want to take some time to review all of the awesome new things that we have learned in this unit, because some of it we did at school and some of it we did at home. So I kind of want to go over everything. All right, so we started this unit in the classroom where we started talking about how different things have different properties and we can describe things in different ways. You might remember when we did our stations where we went around and we described baby echo and pipe cleaners and popsicle sticks, and we talked about how different things have different properties, and that's what makes them special and different from each other. Then we learned about the states of matter. We learned that there are solids, liquids, and gases. So all of those things that we had described can be classified into either solids, liquids, or gases. And solids, liquids, and gases have their own properties that make them what they are. Solids, like ice, take up space. So they're here, they take up some sort of space, and they have mass. They weigh something. But those are the only two rules for solids. Then we have things that are liquids. The liquids take up space, have mass, they weigh something, but what makes liquids special is that they take the shape of their container. So right now, the water that's inside this takes the shape of this water bottle. But if I pour it into the cup, now it takes the shape of the cup. That's different from the solid because the ice cube stays the same shape. It stays the ice cube shape. We also talked a little bit about gases. Gases are different because they spread out. The stuff inside gases spreads out to fill every part of the space that they're in. So like air fills every part of this room that I'm in. So that's what makes gases special. And then we talked about how matter can change. A solid, like ice, can turn into a liquid, water, when it's melted, when we add heat. And a liquid, like water, can be turned back into a solid, like ice, when we cool it down or maybe put it into the freezer. And we talked a little bit about how if I were to freeze this like this, the shape that it would freeze in is the shape of a glass and not necessarily the shape of the ice cube. So then we started to talk about how some changes of matter are reversible and some changes of matter are irreversible. And to figure that out, we have to ask ourselves, can we change it back? So if I were to take this water and put it into the freezer and turn it into a solid ice, could I change that back? Could I change the ice back into water? Yes, I could let it melt and then the ice would turn back into water. So that makes this a reversible change. If I were to let this ice cube melt, let the heat get to it and let it melt, could I change it back into an ice cube? Yeah, I could. I could put it in the freezer and it would change back into an ice cube. So that's a change that is reversible as well. Let's talk about some other examples of reversible and irreversible changes. You have a piece of paper. Crumple it up. Can you change it back into a flat piece of paper? Well, yes. It's not a perfect piece of paper anymore, but you could change it back. This is a reversible change. But if I take the paper, rip it in half, am I ever going to be able to turn it back into one whole piece of paper? I could add tape or glue or something like that, but it's never going to turn back into one solid piece of paper without something else helping it. So that change, ripping the paper, is an irreversible change. I can't change it back. Here's another example of an irreversible change. If I take a bowl and I crack an egg and I pour some milk and I add some pancake mix, I'm making pancakes. Can I change, once I poured all of those ingredients into my bowl, can I change them back? If I crack the egg and I pour the milk and I put in the pancake mix, can I then take them back out? And can I put the pancake mix back in the box and the milk back in the jug and the ice back in the egg back in the shell? No, once it's batter, that change is irreversible. I can't change it back. So we talked about reversible and irreversible changes. And then we talked about something super cool, physical and chemical changes. And when we think about physical and chemical changes, we have to ask ourselves, is it still the same material? So let's talk about this batter. When I put the egg and the milk and the pancake mix into the bowl and I mix it all together, is it still the same material? Yes, they come together to form batter, but the only thing that's really changing is the physical properties of it, right? The egg is mixing with the milk, and the milk is mixing with the pancake mix, and it's all kind of becoming one new material, but it all still has the same parts in it. It's still eggs, milk, and pancake mix. But when I take that batter and I stick it into the oven and I cook it, or I put it on the stove and cook it up, that's a chemical change. Once it's cooked, it's pancakes. That's something brand new. So the batter, turning all these ingredients into batter, that's a physical change. I'm changing the physical properties. But when I cook the batter, the chemical properties of it are changing, and it turns into a pancake, which is something brand new, a brand new material with brand new properties. There are some other examples like this. If I take that piece of paper, move my milk out of the way. If I take that same piece of paper and I rip it again, it's an irreversible change. I can't change it back, but it's only a physical change. This is still paper and this is still paper. But if I were to take a lighter and light this piece of paper on fire and burn it, that would be a chemical change. When something is burning, it's turning it into something new. A chemical change is happening. This paper is no longer paper once I've burnt it. It's ash. It's something new. So if it's burnt, chemical change, but just ripping it, physical change. Another example of a chemical change is rust. When rain comes down or water gets into metal, it changes the material of the metal and it turns it into kind of that rust, that like orangey stuff that you might see. That is a chemical change. It's not the same material that it was before the rain or the water got into it. So that's another example of a chemical change. Another example of a physical change would be breaking things. If I take this egg and I crack it into the bowl, it's still an egg. Nothing's changed about its properties. It's just a physical change. It's just a physical change. The egg has been cracked and now the yolk is inside the bowl. But if I were to take this egg and I were to cook it on the stove and turn it into a hard-boiled egg, well, that would be a chemical change because now the whole entire egg is very different. What it is different. It's no longer this raw egg. It's now a cooked, boiled egg. So that is a chemical change. There was chemical changes happening when you cook something. So we learned so much. We learned about physical changes and chemical changes. We learned about reversible and irreversible changes. All chemical changes are going to be irreversible. Once I cook this egg, that's an irreversible change. I can't uncook it. Once I cook those pancakes, I can't uncook them. Once I burn the paper, I can't unburn it. But some physical changes can be changed back and some can't. When I crumpled the paper, I could change it back. But once I started to rip it up, I couldn't change that back. But both of those were examples of physical changes. On your test, you're going to be given a bunch of different examples of changes that happen, and you're going to be asked, is this a physical change or a chemical change? Or you might be asked, is this a reversible change or an irreversible change? Make sure you're asking yourself the questions, can we change it back? Or is it still the same material? Right, it was so much fun learning all about physical science and the states of matter and how things change with you, and I can't wait to start our next unit.